Just take a look around you for a second. That phone you're holding, the chair you're sitting in, maybe the mug on your desk, every single one of those things has a story, an origin story, really. So today we're going to dive into the absolutely incredible world of modern manufacturing technology. I mean, for real, have you ever stopped to think about how the very device you're watching this on right now came to be? It's amazing, right? It didn't just pop into existence. It was designed, it was engineered, and it was built through this whole series of incredibly sophisticated steps. And all of that is possible thanks to what we call manufacturing technology. At its heart, the idea is actually pretty simple. It's all about using these advanced techniques and tools to turn raw materials into the products we use every single day. This stuff is the engine behind pretty much every industry you can think of, from aerospace to electronics. So, where does a product's journey begin? Well, it's probably not where you think. It's not in some big, noisy factory. It starts in the digital world. Let's dig into this first stage, creating what's called the digital blueprint. Yep, that's right. Before even a single piece of metal gets cut or any plastic is molded, everything, and I mean everything, starts as a design on a computer. This digital blueprint isn't just a picture. It's a super precise set of instructions that tells a machine exactly what to do, down to the tiniest fraction of a millimeter. Okay, so how does that digital plan become a real physical thing you can hold? Well, it happens thanks to two key technologies. First, you've got additive manufacturing. You probably know it as 3D printing, which builds objects up layer by tiny layer. And then you've got its opposite in a way, CNC, or computer numerical control, that uses computers to guide machines that cut and mill material away. So one adds, the other subtracts, but they're both following that exact same digital script. All right, we've got our blueprint. Now we're leaving the design studio and heading out onto the factory floor. This is where those digital instructions come to life and actually build the product. Now, this is not your grandfather's assembly line, okay? In step one, you've got this hyper-precise cutting using things like water jets that can slice through solid steel with just water and tiny particles. It's wild. Then in step two, you have these incredible robotic arms taking over for things like welding or moving huge parts with perfect, flawless consistency. And for step three, all of this work is being done with these amazing advanced materials, like super strong composites and super alloys that make our products lighter and way more durable than ever before. And that right there really gets to the heart of it. This is why we use these systems. They improve precision, consistency, and efficiency. It's not just about being faster. It's about making a better, more reliable product every single time. But just building the product is only half the battle. How do you make sure every single one that comes off the line is absolutely perfect? Let's move to the next stage and see how manufacturers are perfecting the product, making it better, faster, and most importantly, smarter. So here's the puzzle, right? How do you make things better without just working harder? The answer isn't about throwing more people or more hours at the problem. It's about optimizing the entire process from the very beginning to the very end. And this is where this brilliant philosophy called lean manufacturing comes into play. The core ideas are all about eliminating any and all waste. And that could be anything from scrap material to the time a product just sits there waiting for the next step. Then, by reducing the lead time, the total time it takes to get from a concept to the customer, you get this massive boost in overall efficiency. It's just smarter. And look, this isn't just a philosophy. It's backed up by some seriously powerful tech. You have quality control, which uses things like non-destructive testing. Think of it like giving a product an X-ray to find hidden flaws without damaging it. Then you have flexible manufacturing systems that let a factory switch from making one product to a completely different one, like on the fly. And finally, you have green manufacturing, which is all about reducing waste and energy use to make the whole process more sustainable. It's this awesome three-pronged approach to perfection. So, we've seen how things are designed, built, and perfected. But honestly, the most exciting part is where all of this is going next. We're moving away from the era of mass production and into something way more personal. Let's call it your production. This comparison right here, this captures the entire revolution we are living through. The old way was mass production, right? One single design made for millions of people. But the new way? It's mass personalization. It's the ability to create a million unique designs, one for each individual. And we're not just talking about custom phone cases here. We're talking about personalized medical implants,
Cars configured exactly the way you want them. It's a complete shift in how we think about the products we buy.
This changes everything. The power literally shifts from the factory to you. Just think about that. Instead of just choosing from whatever's available, you get to have things made for you. It's manufacturing on demand, tailored specifically to what you need and what you want. It's uniquely yours.
And what's making all of this a reality? Well, it's that perfect combination of everything we've been talking about. The whole system is driven by digital technology, creating those blueprints, automation doing the heavy lifting, and data constantly feeding back to optimize the entire process. So after this whole journey, from a simple digital idea all the way to a personalized product in your hands, what's the big takeaway here? It's really this. The world we live in, it's literally built by these technologies. They are the invisible architecture of our modern lives. So the only real question left is, with tools this powerful, what are we going to build next?